Okay. Thank you all for joining. This is a presentation on how to produce fast orthodontic models with the new material from Formlabs and the dental team on our dental printers like the Form 3B and Form 3BL. Thanks for joining me. This presentation is going to be pretty comprehensive with an orthodontic focus. And to begin, a little bit about myself. My name is Sam Wainwright, the dental product manager at Formlabs. I've been in the dental industry and using dental 3D printing for over 10 years. And I have experience in support and sales and, of course, product management, and been at Formlabs for about 3 years. So the agenda, it's pretty rough, but you can see we have an introduction to Formlabs really quickly, the walkthrough on how to make orthodontic appliances with thermoforming, the new material that is alluded to in the title, this fast model material, and a little bit of the process and how it was developed and why it's so unique and different in our platform and portfolio. And then I'm also going to review all of our dental materials, maybe some not as relevant, a little quicker than others. And then talking about the Form 3B, the ecosystem, and the components. And then some next steps and Q&A and stuff like that. So Formlabs, more and more businesses are choosing 3D printing and Formlabs Dental. And many don't know this, but Formlabs is actually a 500 plus person company with headquarters in Somerville, Massachusetts, which is right next to Boston. And we also have one of our big locations in Berlin, Germany. But we have 7 office locations around the world. And the Formlabs Dental team is a business unit inside of Formlabs, which I'm proud to be a part of, that is completely focused on the dental industry with experts in the field. And why that's so important is because, as you all know, dental is not easy. The demands, the requirements are much different than just, say, engineering parts for 3D printing. And it's a very comprehensive digital workflow that we're a part of, right? There's front-end steps and processes, as well as finishing and all that, and delivering actual parts and appliances to patients, and if you're a laboratory, your practices, your customers, so forth and so on. And Formlabs, actually, the majority of our materials are made by Formlabs. And these are some of the most recent biocompatible materials that we've developed, engineered, and manufacture in-house. And this is all done in our Ohio manufacturing facility and the team there, as well as the teams in Boston, Massachusetts, and should give credit to all the good work that the team in Berlin does on the dental team to help with this process as well. They should be represented on this map as well. But our customers and our users have printed over 200,000 biocompatible appliances like surgical guides or splints, and with not including including biocompatible and all other dental parts, our customers and users have done over 10 million parts. And this number is probably a little bit low at this point. It's simply amazing how much usage and sort of a leading sort of indicator that adoption is here for these technologies. Digital dentistry and 3D printing is a huge part of it, and it will continue to be. So the Form 3B and then the clear retainer or aligner walkthrough basically has 5 major steps, including 3D printing and not. The blue arrows here are where we are very much a part of the process, but otherwise it starts with a 3D intraoral scan, so capturing a digital impression, taking those files, preparing them in a CAD software, which we'll get into a lot more detail on, printing those parts, finishing them, or washing and curing them, then forming them if we're talking about a thermoformed appliance, and then delivery or patient takes them home. And so, like I mentioned, this is going to be going through how to thermoform a clear aligner or retainer end to end. And so to start with 3D intraoral scanning, it's an important point with digital impressions that you want the the files as an STL file, and this is an example of what it would produce. This is actually off of a 3Shape Trios, and once you have that design, that digital impression as an STL file, you're now ready to move into the CAD process or preparing it. And there's going to be two major groups I want to point out before getting into the real detail here. But for orthodontic appliances like thermoformed appliances, aligners, and retainers, there's really two main outputs and differences. So aligner models, it's a treatment plan. It can have many steps to it, and you're thermoforming or creating many different clear appliances during that treatment process. This is sort of just a visual representation, but there are many treatments, as you all know, that can be 20 plus steps in the overall treatment. So it's quite a bit of models, and the CAD software is critical to producing these parts that are 3D printed and made. A replica model, which is obviously just like a diagnostic or just a replica of the patient's anatomy and dentition, is ideal for retainers, clear retainers that are thermoformed, or other orthodontic appliances like Hollies or what have you. For aligners, there is a lot of software on the market now. A lot's changed in the past couple years, but I still think that 3Shape's Clear Aligner Studio is probably the premium offering in the space. And I just wanted to point that out as sort of like thinking of this as like two camps. Like sort of the most comprehensive, the most powerful software to make aligners. 3Shape Clear Aligner is in the top of that for my mind. And then on the other side, sort of the simplest workflows, making just replica models, we just recently released a software tool in our preform job setup software called Scanda Model, which is great for just taking raw digital impressions, bringing them right into our software, adding and trimming, putting a base on them, and printing them for these replica thermoformed retainers and what have you. So that's kind of like the two ends of the spectrum. To get into a little bit more detail in software, it's worth mentioning, and let me just see if I can turn off my face for just 1 second so you can see the whole thing, and if you want to grab a screenshot, that's cool. This is a pretty busy chart. I'm going to go line by line through it. But before I do that, it's worth mentioning this is from information from my team and myself on the softwares in the market. There are other softwares for sure. There could be sort of pricing plans that are different than what I'm saying here, or functionality that's different. This is the best of my ability. This is not an absolute. Hopefully this is a good just starting place to give everybody some ideas. But you can see here on the top row all the software that is typically used for these types of applications, so replica models or aligner treatments. And excuse me a second. And if you notice here, as just an example, for our Scanda Model software is free to use with a Form 3B printer, even a Form 2 if you have a legacy printer, and it is great and ideal for making replica models, like I mentioned earlier, right? Now, the free to use is a critical point here because there are other options on the market. So like there's a mesh mixer, blender, a little bit more technically challenging, but a bit more powerful tools if you want to really get into it. But this is really what I would recommend somebody just getting into this, maybe a little less technical. This is definitely the approach. These other softwares, although free, are much more challenging. You need to have sort of some CAD experience, which many don't. There's three other business models that are worth pointing out here. So an upfront purchase means that it has an initial purchase price, and then there could be some annual sort of subscription or licensing fees otherwise, but it's pretty much unlimited usage. So this is really 3Shape and ExoCAD. These are the Cadillac of dental CAD softwares on the market, not just for orthodontics, but restorative dentistry and over implant prosthetics and what have you. And then pay per case. So this is, you have a case, you pay for each case you do, which is nice because there's no barrier to entry on the cost point. But there's two ways to approach it. There's either pay per case you design, so you use their software usually through like a cloud service on a browser, or pay per case and they design. You just send them your specifications, your prescription, what you want done. They send you back the files designed and prepared to that spec. So those are the business models we're sort of looking at with all these softwares, and then functionality of these softwares. And so replica models, right? Many of these will do replica models, and a lot of these softwares will have more functionality like hollow models and engraving and other things. I think a good one to point to is like EasyRx. It is a pretty easy, pretty powerful software that I would definitely check out. And then treatment planning or aligner models. So this is, again, what I was mentioning earlier. This is for a really pretty robust CAD software that allows you to set up cases as you would like them in ideal world, and then it generates these steps in the models to go from A to B. Full base control and virtual articulation. What I mean by that is the ability to have more advanced features in creating models. So like if you want to add an ABO base to the model, if you want to do some virtual articulation in the software, many of these softwares will allow that and give typically just more control, more power to the user and whoever's designing this case. And then bracket removal tools. I put this in here because I think this is critical for anybody that wants to take a digital impression and save yourself an appointment by digitally removing those brackets to make a retainer. So the final appointment, you have the device, the retainer, ready for the patient to take home. This is pretty cool. I think this is valuable in of itself. So I just want to make sure that that feature was noted in, say, 3Shape, exocad, or EasyRx, for example. So that's all of them. It's a bit complex, I know, but it's great that there are so many options on the market today. I think 4 years ago, this list would have been much, much shorter. So a lot's changing rapidly. So this could go like out of date pretty quickly. That should definitely be noted. So this is ever changing. Probably the best guess for Q1, early 2021. So if you're using one of these dental CAD softwares, say like 3Shape, you need to get your manufacturing files, your model files, exported as an STL file to bring into Preform. And how do we actually manufacture it? Well, we bring those files into our Preform software, but before that, we need to choose a material that's appropriate for what we're doing, bring those STL files, those manufacturing files into Preform, set them up, send it to the printer, you print, wash, and cure, and then you're ready to make the appliance. Choosing a material, I'm going to get a lot more into detail on materials and applications later, but we have lots and lots of different materials. It can be a bit overwhelming, but really for fast, accurate, great thermoforming models, I highly recommend our new Draft V2 resin. Again, I'll go into more detail later. Once you have that all set up, you bring it into Preform. Preform is a free-to-use software which is very intuitive, but also has some really powerful manual controls once you dig a little bit deeper. And what it allows you to do, pretty much, job setup, nesting, CAM. You take your manufacturing STL files and you virtually place them on the build platform. It can check to make sure it's got correct printabilities. It can estimate material usage, print time, and all that. And then you send the job to the printer. There's flat to the build platform, and then you can also do them vertically as well. It was a little bit odd sort of shoehorning Scanda Model in here, but hopefully this makes sense. I wanted to talk about it a little bit because it's a new software. It's really exciting for many that are just getting into this. Like I mentioned, Scanda Model will take raw digital impressions, STL files. You can bring them right into Scanda Model and then base them and make them parts that can actually be 3D printed with no other CAD software. Great for replica models, patient presentation models, diagnostic models. And what that looks like is it's a tool within Preform that I was showing where you import those raw scans. Here's just a quick video of me finding the file. You rotate this raw open mesh digital impression into orientation, so the occlusal side is away from the build platform. We have a trim tool, so you can use this plane cut trim tool to trim up the extraneous data, and then you can add a base height. This is an optional step, but let's just say it was a little short, you want to add a little more, or palatal model. A base height is a great tool to have. Once that's done, it calculates out the job, and this model is now solid and ready to be printed. So it's really pretty quick, very easy to use. It's purpose-built, so it's not complex software or anything else like that. But again, coming back to if you just are using another dental CAD software, the STL file is what you'll need to bring it into preform. If you're using Scanda Model, it's going to just be ready for you to set up from there. So if this is just an example, say you bring in your files and they're all over the place, really quick to just snap these down to the build platform, set them up, play a little Tetris, and send the job to the printer. It's very intuitive. The controls on screen are big and easy to use. Fantastic software overall. I really enjoy using it. And then you just send the job to the printer. You select your printer, it sends the job over, and it can be, the printer's connected either through Ethernet, wireless network, or even Ethernet if you have want to be off the internet with the system for some reason. Preform requires no internet, so like I mentioned, using USB to connect to the printer. No internet required, no licensing, no dongles, so you're never blacked out if like a dongle service is down. Scanda Model is on the Form 3B, Form 3BL only, and our legacy Form 2, so that's an important thing to note. It's Mac, PC, I mentioned the connectivity. It allows for remote printing, and it also has optional updates for the Form 3B as well. Remote printing is really cool. It allows you to prime the printer, so you can set up the printer, get it all ready, and then you can send a job to that printer and have it start automatically at any time, any place, which is really, really neat. I use it all the time. I've been working from home for a while now, but my office is on the second floor of my house. My printers are in the basement. I can prime them, go upstairs, drink a cup of coffee, send my jobs, and I know they're going to kick off and start on their own. Dashboard is also fantastic for this sort of remote process as well. It allows you to see your printer or printers in a really cool timeline overview, what prints you've done, how much material you've used, how much you have left. It's really a fantastic piece of software as well that really will give you a lot of information and what should be done or what's going on. So with all that said, on the software side, we're ready to now 3D print the model. So like I mentioned, the material, we're going to be using draft. The images here are surgical guide, but just ignore that. All the materials, our materials come in cartridges, which allow for the resin to automatically dispense into the tank. So no pouring resin or handling it really in a major way. You put in the build platform, the resin tank. Once you start the print, it automatically dispenses. And importantly, if it's a big job and it runs out in the middle, it doesn't just fail, it fills itself automatically. So it really allows a lot of unattended manufacturing, especially overnight for big jobs. This is a time lapse of some splints that are being printed, which I thought was pretty neat. But the printer literally uses light to photo cure these resins and make physical parts out of them. Now, what we need to do next is wash and cure the parts. This is a requirement for all photopolymer printers. So it doesn't matter if it's LED, LCD, or DLP, or SLA like our printer. These uncured resins that can be left on the models need to be washed off. And we've really made that process a lot easier and pretty affordable as well. Our washing system is a really nice set it and forget it. Sorry, I'm getting ahead of myself here. The models they can be actually washed directly in the build platform if you like. I personally like to remove them from the build platform and use this deep fryer basket that also comes with the wash system because I like to move my build plate into my next print. But the wash is fantastic. You can set with really simply on the knob how long you want to wash the parts, say 10 minutes. And the best part about it is when it's done washing, it pulls out and starts drying for you automatically. With other washing systems, you really have to be there and you can't sort of let it sit in that IPA because it'll degrade the part over time. So this is great. You set it in the wash, you can go to lunch, you can leave for the night, and the parts will just be waiting there, not soaking in the IPA, destroying your parts. Set it and forget it sort of thing. Here's a photo of that deep fryer basket I was talking about, which I like to use a lot. And it also allows you to get away with using a little bit less IPA than full on a full build platform wash. Form cure is just as easy as our form wash. It has a knob. You can set the time and the temperature. And it's a really nice, affordable unit that has precise heating and UV curing. And again, it's set it, forget it. You put it in there, you set your time, you go, and you can leave. You don't have to sort of babysit it or anything like that. And really amazingly, our new draft resin, the one that I'm going to be highlighting in a bit more detail later, only has 5 minutes of cure time. Some of our other standard resins have 30 minutes with heat, which can be really 40 minutes. So 5 minutes is a huge impact for those that want to make these parts and appliances rapidly. If you do support your models like what's shown here, the Form 3B really does fantastic, very small touch support tips, easy to rip them off, does a good job of not creating divots, but actually leaving a little material behind, which is what you want when you thermoform. You do not want a divot because otherwise the plastic will be larger than the anatomy. And that's really the 3D printing workflow. Once you've printed, washed, and cured, you're ready to move along. So you have your material, you bring it into preform, you print, wash, and cure, you're ready to go. Now comes to the actual application fabrication. So we use a Drufomat pressure former, which I highly recommend pressure forming over vacuum forming. But really, fundamentally, what this unit does is it heats the sheet of plastic, of varied heights. So, these sheets come in as thin as 0.6 millimeters, and I personally like a 1 millimeter thickness for my appliances, retainers, and even aligners. The thicker the material is, typically has more memory, it can apply more force to the teeth, opposed to thinner. And you got to remember, when you're stretching and heating these plastics over the model, they do thin out a bit. So when you get a 1 millimeter sheet thermoformed like this, it'll thin down to about 0.7 millimeters, which is important to note. So once you have that thermoformed part, you pull it out. You need to cut it out of the sheet and finish it. So there's lots of different ways to make these appliances, finish them, cut them, and everything else. This is the technique that I personally like. I think it's important to note that it will be different for the thickness of material, the brand of material, and what you're comfortable with, right? I like to take a sturdy pair of scissors, make an initial cut in towards the lingual side of the arch, as you see in 1, then make a rough cut where you see on 2 with those same scissors. And you can see this is an example of a pair of scissors or shears that are a little bit beefier, just for these rough cuts. Then once you have the rough cut, on the rearmost molars, you trim almost like a U around the backside, not cutting the anatomy, but it's really giving you a pry point to get the appliance off the model. You trim that with a cutting disc or wheel, low speed handpiece, even a high speed would work, of course, and then use almost like this little shoehorn to pop the appliance off of the model. Once you have the appliance off the model, I like to use this technique shown here, where I use very sharp, precise scissors to trim around right to the cervical margin. And I also highly recommend, on the lingual side of the appliances where it gets tight on the interior teeth, I like to have curved scissors as a secondary, because cutting that curve with straight scissors or even semi-straight scissors can be a little bit tricky. So have a couple different sets of scissors, make sure they're sharp, replace them when needed. They're pretty affordable, so it's not really a big deal overall. But this is the huge benefit to doing it like this, opposed to trimming with a cutting disc directly, is the edges, if done right, can be very clean and really need no processing afterwards. Some use cutting discs and trim to the edges, and then use a Scotch-Brite or a buffing wheel to trim off that flashing. I don't really love that process. It's also kind of messy. So if you do it once correct with a sharp pair of scissors, it really saves time, in my opinion. But again, whatever works for you. There are some advantages and challenges to making these appliances in-house. And this is for clear retainers or aligners, both of them. So the advantages are, this has never been easier than it has been before. If you were to try to do this 3 years ago, I think it'd be a completely different equation. The printing technology, the workflow, the software is just more accessible than it's ever been before, and it's getting more and more accessible as we move forward as well. It's a much simpler workflow and flexible than it once was as well. There's a huge time and cost savings in making these appliances yourself. you know, to all in with the resin, even the CAD software, and labor, you know, you can make an aligner case for like around $200 all in. And the model component is actually kind of one of the cheaper parts of it. The labor and the CAD typically is the most expensive part. And obviously this will vary based on the situation. And, you know, it's great to have these cases, these files digital. You can make them at any time, on demand, fantastic. Some of the challenges, there's a learning curve. I'm not going to be honest, right? This is something that you need to approach, you know, as high-level workflow. You need to know what you're getting yourself into, break it up into these bigger steps. Who's going to do what? What do you need to do, say, the finishing, or even do you need a computer, you know, for the printer? Because you don't want to run the preform on your 3D intraoral scanner computer, for example. And you don't want to run it on an older computer that you're using for your books, right? You want a fast, modern PC, desktop ideally, that can be dedicated to doing this type of work. So there's a lot to it, but understanding it and getting expectation setting is important here, and I think that's my biggest point on challenges. Just know what you're getting yourself into, and all the parts and pieces that you would need. So our dental materials and applications sort of overview, high level. This is our printer and some resin cartridges, as you can see. There's a whole host of materials, and I'm going to go through every one of them right now. And when I talk about you know, layer height, so like 100 microns or 200 microns, this is kind of a nice simple visual way to show it. Bigger layers will make the parts have more steps to it, or less steps to it. So like on the left here, you can see bigger layers, for example, 200 microns will have bigger steps in the part versus smaller layers. For example, 100 microns would be half, because it's doing twice the amount of slices and layers in that print process. So a little bit of context here when we talk about like layer heights and all that, this is what that means. Draft V2, this is a little bit of a tangent here, but I hope you find it interesting or valuable in some of the nuggets I have in here. But Draft V2 is our latest material that I think really changed the dynamic for these types of models and orthodontic appliances being created on our printer and system. It has two settings, 200 and 100 micron settings. Both are fantastic for appliances, orthodontic appliances, and really there's three things I want to go through. One is a little story about the discovery of this product and how it came to be a product. 200 microns is a little deep dive into what that looks like, and then 100 microns. So over the summer in 2020, the materials team came up to me and were like, hey, we have a material we'd like you to try. It's Draft V2. And, you know, we had a version 1. It was okay. I didn't love it. It was not the most accurate material in the world. It was 300 micron layer height. It was okay. It was fast, but it was just right? And okay, we'll see. And so to dig a little bit into the process when we do dental applications and validation and testing, we use master models. We used to do stone, but stone gets worn out and changes, so we switch to metal master models. And what we do is we print these master models in all sorts of orientations and positions to check fit and accuracy and everything else, not just in 3D scanning and comparison, but also physical making of these applications. How does it fit back to the master model, right? And we do many other tests as well, like for print reliability, we'll do really small, thin models, but this is really for tuning and making sure it's meeting our spec high level. Like, is it going to work for this application in this orientation, for example? This is a macro photograph of 200 microns. A print, actually one of the first ones I did many months ago. And as you can see, the facial anatomy, even at 200 microns, was absolutely beautiful. I mean, I was kind of blown away when I first saw the model. And so just like I had explained before, we thermoformed on those models. And sorry for the bad photo here, but this is the first appliance I made on Draft V2 200 microns. And I thought to myself, hey, that doesn't look too bad. I think it's also important to note that the largest aligner manufacturer in the world prints their models at 200 microns. So there might be some sort of sweet spot in there, but I'll let that let that for you guys to decide. We put the appliance back to the master model, and I was blown away by the fitment. That first day, I printed, the team printed, and I thermoformed and cut out 6 appliances on parts that were printed flat to the build platform, and then 6 that were printed near vertical at 200 microns. And the fit every time was absolutely perfect. I was totally blown away. This is nothing like I had seen on our first version of Draft. And this is the fitment of the vertical print. And as you can notice, since it's printed vertically, the layer lines are on the facial anatomy. So I thought to myself, okay, well, that's not great, but the fit was fantastic. Even at 200 microns, I was like, wow, this is great. And then I started digging into the speed. So this is gray was our sort of go-to material for these orthodontic models. As you can see in the leftmost column, gray 100 for this print above. These are pretty tall models, keep in mind. Shorter models greatly reduce print time, but these 2 model sets in gray 100, these are actual print times, was about 4 hours, and it had a UV cure of 30 minutes at 60C. So 4 hours and then 30 minutes at 60C, you know, you're talking almost 5 hours all in. With washing and everything else. Gray 160, which was our previous sort of fast ortho model solution, 2 hours and 30 minutes. Better, but still not that fast. These same prints in Draft 200, amazingly, over twice the speed of Gray 160. Less than an hour to print these, and the UV cure being only 5 minutes with no temperature is huge in cost savings. You know, that's 300% faster than Gray 100, 165% faster than Gray 160, and over 200% on Gray 160 if you include UV curing. So I was like, whoa, this is like next level material here. This is really exciting. So I did one more. This is a single arch, super, super low. Like I set this up to be like, what is the fastest model I can print and still sort of get away with it? This is trimmed as low as you can go, smallest model possible. Amazingly, as you can see here, Gray 100, 46 minutes, pretty slow. Gray 160, 28 minutes, not bad. Draft 200, 16 minutes. It was, it kind of blew me away. And 5 minutes at no temp. If you had to do 30 minutes, even if Gray was at 16 minutes, you still had to do 30 minutes at 60C. You know, that's still too long. If you want to do an appliance in an hour, 2 max, it's just not going to work. So I have another example here I want to show that compares this material on the Form 3B versus one of the most popular chairside DLP printers on the market and their gray resin. A single horseshoe arch printing on their system was about 21 minutes, including their just their cure. Total print time for one arch was 1 hour and 6 minutes. That same printer, 7 horseshoe arches, print time impressively 35 minutes, and with UV cure about 1 hour and 20. So not a big difference between one model and 7 models on their system. Amazingly, that's those same jobs, those same prints on the Form 3B with this new Draft resin. The print time 16 minutes with wash and cure. I did include wash in there. I think it was 10 minutes on both. 30 minutes total time for a single arch. Approximately 31 minutes. Of course, these are like ideal scenarios, so keep in mind, grain of salt totally added there. 7 horseshoe arches, our print speed was a little bit slower, but since our post-processing was so much faster, we actually were able to make those 7 models ready for appliance manufacturing faster in just a hair over an hour. So really interesting. SLA, which was known for sort of like slow print speeds but high quality, we're now in that same range as the LP, which was really cool to me. The Form 3L also has Draft now, especially now it has Draft 200 and Draft 100. I don't have the 100 speeds in here, but it took our prints in Gray 100, that this is I think 24 models at once. That was a 10-hour print time, and brought it down to 2.5 hours. I've even seen users online now posting that they're printing, you know, like say 20 models in 1.5 hours. So it made a huge difference for the Form 3L, and anybody doing a lot of aligner or orthodontic model production, this is going to be a big deal. So why is Draft V2 so fast? Well, in theory, it's just more reactive material. So it's in theory, right? So this is gross simplification of the material science, but it's twice as photoreactive as gray or model resin. So the laser, our printer, can just move faster and the resin can keep up with it. And that's also why the UV curing, post-curing is so much faster. So really, really fantastic. To get to the accuracy, so we always do a lot of invalidation and testing. We do a lot of prints, a lot of scans, and we compare those scans to the original file. What does that really look like? So here's our manufacturing file for our metal master model. We print it. We then use a very high precision desktop 3D scanner, which is accurate within 8 to 10 microns. And with that scan of that model, we compare it to the original manufacturing file. Overlay those two, and we say, okay, in the print compared to the original, how much deviation on the surface do we have, right? Excuse me. At 200 microns, we saw, at 200 micron prints, we saw 98% of the surface was within 100 microns of the actual manufacturing file or the actual scan, which is well within what is needed for orthodontic appliances. And in my mind, in sort of the development cycle, I was thinking to myself, wow, this is really, it's hitting the three things that we really need. It works, it's accurate, and it's fast. Here's some photos of some thermoformed parts on some Draft V2 200 micron models, and these are 1 millimeter sheets. Here's a macro photo of that appliance fitting over the metal model. You can see just the fitment, everything else. It's beautiful. Some intraoral shots here. You can see the facial anatomy looks fantastic. I mean, it's very, very comparable to aligners in the space. Otherwise, the fits are great, really just fantastic. Here's a more relaxed photo of that same patient. We also did testing for traditionally made appliances, orthodontic appliances like Hollies. Here's this Holly was made on the printed Draft 200 part, and then we fit it back to the master model. Again, absolutely fit like a glove, beautiful. And then this got me thinking, we need 100 microns. We need to be able to support vertical printing of these parts for maximum output. And we want less layer lines for those who want to deliver even better parts, or less sort of, it's perception really, right? Invisible layer lines, we'll call it. This is the example I pulled up earlier. This is 200 microns vertical. We need to reduce this quite a bit. So 200 microns was what, 100 micron settings is what we need to do next. And as you can see on the left here, so Draft V2 200 microns within 100 microns in our accuracy testing. And something I didn't mention earlier, these are averages. We do these prints over many printers and many models, and then we take the average of all of them. So we don't cherry pick this data on one great printer. We do it on 6+ printers and then average the bunch, so we get a real representation of what the average user should see in output in sort of normal circumstances, right? So Draft V2 at 200 microns, impressively 98% within 100 microns of surface. Draft V2 at 100 microns, 99% within 100 microns of the surface. Well, that's not a big difference. If you move that tolerance to within 50 microns of the surface, all of a sudden you see 200 microns at 80%, which is still very, very good. 50 microns is a very tight tolerance. That 100 micron setting was almost 90%, so 89% within 50 microns of the original file, the original surface. Just really incredible. Quick comparison on the same ones I did earlier on 200. This is Draft 100. You can see this same print that I showed. If you're comparing Gray 100 to Draft 100, half the time. Not even talking about UV cure, amazing. Here's all 4 of them side by side. Really, really so productive. Draft 100 at 100 microns is my favorite material. I use it all the time, just for even fun stuff, that I want to print. It's just so productive. It's beautiful prints. Here's a 7 model job. You can see Draft 100 did these 7 models, actual print time in 1 hour and 17. Wash is about 10, UV cure is 5. So 7 models in 1 hour and 30 minutes roughly. Draft 200 cut that time by about 30 minutes. Side by side, so on the left here you can see this is the same print at 100 microns, on the right 200 microns. I mean, both are beautiful, but really you can see the difference with this photo of what the two look like. Vertical printing, again, one of the main reasons why I wanted to do 100 micron settings. Gray 100 for this packed build platform. I believe this is, how many is it? 18? What are we at here for? Yeah, it's 18 models. Yeah, that's 9. Yep, 9 on each side, 18. Gray 100, actual print time here, 16 hours and 53 minutes for this job. Oof, brutal. You couldn't do this in a working day. This would be a full day process, right? Draft 100 took that print and cut it down to 5 hours and 30 minutes. That means you can do this print in your working day easily. That's game changing in my opinion. It's 18 minutes per model. Here's some nice photography that I took of that print. You can see the layer lines much less apparent than on draft 200. Really, really beautiful prints. Here's what a Form 3L, Form 3BL print volume looks like. I mean, it's just a daunting amount of models, but as you can see, incredible. And then Scanda Model, which I showed earlier, plus draft, really unlocks some pretty amazing potential. We have almost a complete workflow here, right? So if you have a digital impression, an STL file, you can just bring it into our ecosystem and go right to bench, finishing, and making the appliance with thermoforming. And what that means is I've broken it out into 6 steps. What does a same-day appliance look like with Scanda Model, which is free to use with our Form 3B, Form 3BL printer, and all the associated steps. Now, again, take this with a grain of salt. This is an estimate, but you can see here, step 1, digital impression, let's just say 10 minutes. Of course, some people are faster, some people are slower. Scanda Model, it takes about 5 minutes to process 2 arches, a model set, right? Print time, and this is even, I wanted to do 3 models here in this example to give myself a little bit of buffer, to be a little conservative. Print time on these 3 models, 28 minutes, wash about 10 minutes, UV cure 5, and appliance fabrication another 10. That means you have appliances leaving with the patient in just over an hour, 68 minutes, right? An hour and 8 minutes. Pretty incredible. Even if you put in, say, another 20 minutes of working time or margin of error, that's an hour and a half. You have appliances out the door with the patient. Really, really interesting, and I'm excited about Scanda Model and what this can unlock for so many that are hesitant to get into it because of the CAD component. Here's some photography of that print here. Just nice hand-holding shot there. These are, to give it into our rest of our materials, that sort of summarizes draft overall. We really have 3 model materials in our portfolio. We do have gray. That's what we were using for orthodontics before. I think it's still a great material, but it's sort of bumped off this list in my opinion because its usage is a bit vague now if you have compare these 3. But draft is what I recommend for orthodontic models. Fast diagnostic study, thermoforming, appliances, all that stuff is my go-to. Model resin is a more matte, not nearly as quick as draft, but beautiful sort of looking. They feel great, and ideal for restorative models, restorative cases like crowns and what have you. White is mostly for presentation models. So patient presentation models, you're showing treatment plans. The patient doesn't understand 3D printing. They might not know why they're being shown in gray, their teeth in gray, right? White is nice. It's like pure, bright white. Great for that usage. Here's just some images of the model resin with even cut through on these dies here. More of a diagnostic model shot being held in my hand. And white, again, I think in combination with draft for actual production of appliances, great for study presentation models. Here's another shot of it in that same model, that same case built in Scanda Model. For biocompatible applications, this is getting to be a really filled up section. There's so many resins in the portfolio now, and we just released 2 recently. On the right here, you'll see permanent crown, and then IBT resin, which is for indirect bonding trays, which I'll talk in a little bit more detail on. To start here, we've got Dental LT Clear V2. This is our 2nd generation long-term use material for splints and occlusal guards. temporary CB for temporary fixed prosthetics, custom tray for comprehensive custom impression trays, patient specific. LTV2 is probably the most interesting for this group. It is, like I mentioned, our second generation long-term biocompatible material for splints, occlusal guards, and appliances. It is improved. It has improved durability and resistance to fracture over its previous, and since it's been made and designed and built by us, we've optimized it to the nth degree. It uses 0.3 millimeter touch tips, which is pretty unusual. Most touch tips are like at 0.5, maybe even 0.7. These touch points are so helpful in post-processing. I know it's a minor point, but when you're finishing these things, and I finished a lot of these in my life, it really, really helps having the smallest touch point possible. It's just less work down the road. Here's actually our sample part, and then somebody just ripping it right off to show that 0.3 millimeter touch support tip. I'll talk about sample parts later. I highly recommend just requesting one, even if you're not interested in this product. But it's really cool. It feels great to rip it off. And versus the first version of our material, one of the biggest complaints, other than sort of its fracture resistance and durability, was its color. It was a very yellow material, not great, for perception. People think that yellow is dirty, right? This material is our version 2 is much similar to PMMA. It has resistance to yellowing. Even they almost look even a little bit blue or violet. It's really a much better sort of appliance for a patient that doesn't know dental technology and what they're getting. Just a sort of hero rotation shot here of some parts printed and left on the build platform. And this material is in the US only, EU registration pending, compatibility on the Form 3B, Form 2, it's $350 per liter. And what that means is even with waste, you're at about $5 an appliance, even with supports and waste and everything else. With all of our biocompatible materials, especially, and non-biomaterials, we do a lot of external beta testing. We get feedback in the development process so we can make changes if we need to, make sure it's meeting expectations and everything else. Dr. Ferguson in Florida was really impressed with this material and really believed and was helpful in us sort of proving out that this was the next generation product for us, and appropriately so. I won't go too into depth on some of these things here, but TempCB, as you can imagine, it's for printing temporary crowns and restorations for temporary usage. Custom impression tray, pretty self-explanatory. Surgical guide, short-term biocompatible for drill guides, placing dental implants. Denture teeth and denture paste is a sort of 2-material combination to make full 3D printed dentures. Very cool stuff. Multiple shades and multiple colors. There's just a hero shot of surgical guide. Dentures this is actually all 4 denture base shades. And then here's how they sort of come out, and they're printed, they're assembled, and there's 6 base, 6 teeth shades. I believe it's B1, A1, A2, B2, and then A3, A3.5. Say that 5 times fast. And then permanent crown, very exciting new product we released a couple months ago. First indicated use in the US and the EU for permanent full contour crown usage, single unit, but really cool material, super strong, revolutionary, and a way to make really affordable crowns, high quality affordable crowns, I should mention. IBT resin, probably more relevant for this group. Indirect bonding trays, I'll go through this really quick. IBT resin is a flexible biocompatible material for efficient orthodontic bracket placement. And so the flexibility and tear strength is really important for how these devices get placed in the mouth and how they get tacked into place and then pulled off without moving or jarring those brackets and their tacked placement. This was a material that we developed in-house. We used a lot of KOLs. Its clarity was tested, so when you use your handheld UV cure wand, it tacks correctly. It doesn't sort of want to move after you do this process. and it's been fully validated and gone through many different versions over the year or two that we've been developing. But it's a really fantastic material for anybody that's looking into getting into orthodontic indirect bonding trays and want to make this process a bit more efficient in your practice. The Form 3B ecosystem, the printer itself with support and some basic components like tank build platform and a liter of resin is just under $5,000. Pricing might not be exact here. These are sort of rough and it changes, right? But roughly $5,000 for the printer itself. And this is the one I recommend. It's the printer with our wash and cure, which automated post-processing, making that part simple, is just saves headaches. It's well worth the extra dollars here. But you can get this full kit here for $6,000. And Scanda Model, as I mentioned, is included and usable with the system as well. So really affordable, accessible in price, ease of use is there. Pretty incredible package we have now today in 2020, 2021. Importantly, our dental service plan that comes with the Form 3B is a group of people that are dedicated to the dental industry. I work very closely with them. I get customer feedback. I help where I can on the sort of the tier 2 issues and education, right? We want to make sure our dental customers are taken care of because I personally know, and I know the company understands, that the dental industry is quite different. The demands are higher and every part is different. Every part is custom. It really makes a big difference having a team that understands that and is dealing with it on a daily basis on our hardware and software. Dental.formlabs.com, great resource for our education webinars and videos like this one, white papers, guides, application guides. I highly recommend checking out. We have one for each of our materials and applications. I would also, last point here, I have a YouTube channel, Formlabs Dental, bunch of great videos on Scanda Model there. If you just YouTube search Formlabs Dental, it should come right up. I want to get even more on there, get more people from the dental team making videos. I just love that. I think making a 5 to 10 minute video explaining something in detail on demand is the way to go for that type of content and education, just free and accessible on YouTube, right? Next steps, sample parts. Even if you're not interested, I would request these anyway. They're just cool. You can have them on your desk as a little keepsake. But there's 2 parts I'd point out on this first slide. This is our draft V2 sample, which is an upper and lower model kit with some articulation elements. And then our LTV2 sample is on the right here. And what's really neat is this model would fit to the LTV2 sample. So if you request both of them, they fit together. It's kind of neat. And then you'll have sort of the total picture as well. Also, with IBT, we've launched a new sample part for it. This one's really a great example of draft V2 as well, because the model, as you see here, is printed at 100 microns at draft V2 with brackets built in, and IBT resin at 100 microns as well as the appliance. And the reason we're including a model, because these workflows will typically be modelless, right? You don't need a model to use these devices. You just go right to the patient in the chair. I wanted to show how the appliance fit to the brackets individually as well as cross arch and how they flexed and bend off of it. And if you don't have a patient, to try it on, a model is the next best thing. And again, it does show draft V2 and what incredible resolution quality you can get out of it. That does it for this presentation. From me and everybody on the Formlabs Dental team and Formlabs generally, we thank you. We appreciate your time on watching this, and I hope this was helpful. And if you need to reach out, definitely dental.formlabs.com is the first stop here. But the team, so if you email dental@formlabs.com, it gets to the larger dental team here at Formlabs. And then my personal email is wainwright@formlabs.com. I'm always happy to sort of answer questions over email. It's a little harder for me to take telephone calls, so I'll just put that as a little asterisk. But I hope this was all helpful and informative. Thank you again for spending the time and listening to me.